we're going to be taking a look at humanity's view of the universe. How have humans viewed our place in the universe? How have we viewed space, other planets? We're going to start by looking back in time at Ancient Astronomers, and then we're going to move on to NASA. So if you could write down the question of the day, how has our view of the solar system changed over time? There's going to be a number of astronomers that we cover. This is not even close to all of them, but these are the ones that are kind of the most famous, and we're going to cover for each one. What you guys need to do is in your science journal, write down the name, when they were alive and when they were doing their thing, and then 2 facts. I'm going to go over a bunch for each one. Write down 2 facts about that particular astronomer, and then circle one of those 2, whichever one you think is the most important. These are going to go pretty much in chronological order, so we're going to go the farthest back, starting with Aristotle. He was about 384 BC, so when he was born. He died in 322. He is the one who put Earth at the center of the universe. He is the one that started that idea. We know that's not true now, but he's the one that kind of started it. Because of retrograde motion, where planets start to, or appear to go backwards in their orbit for a little bit, his Earth-centered view, he had these weird little, what are known as epicycles, where the planet kind of orbited around this center of mass. There was no explanation of how this happened, just that it did. And then this little center of mass would be the one that orbited around Earth at the center of the universe. And this is the only way that they could figure out how to explain retrograde motion, where planets seemed to reverse course as they are orbiting. His universe started with Earth in the center. The moon was the closest planet, and then Mercury, Venus. The sun was going to be the third most distant planet, which makes sense because the distance between the sun and the Earth would place Earth right here if you flip-flopped. And then they had Mars, Jupiter, and Saturn. They hadn't discovered any other planets. So beyond Saturn, that's where the fixed stars, the stars seemed to stand still. And it takes many years for stars to seem to move, thousands of years actually, which means they did not have the technology to figure that out. So the stars were fixed on the inside of this giant celestial sphere. The stars stayed in place, and all of the planets just kind of moved around planet Earth. All of this makes perfect sense, because from our perspective on Earth, it doesn't seem as though our planet's moving. It does seem as though the sun moves, the moon, the planets all move. So this kind of makes sense if you think about it. Aristotle was Plato's best student. Plato was Socrates' best student. So it comes from a pretty good line of teacher to students. He was a philosopher, which means he basically had an idea about everything. He didn't do any science experiments. He did not test anything out. There is no scientific method that had been invented yet. He was simply somebody who thought about how the universe should work. He never tested any of those thoughts. He just thought them through, and if they seemed to make sense, there you go. He wrote them down. His thought was that everything in the entire universe had a natural state. So, for instance, if you take a paper towel, its natural state is not to be up in the air. Its natural state is to be as far down as it possibly can, which is why when you drop it, it's going to fall. The natural state of a body of water is completely flat. Even though the wind can sometimes make waves, its natural state is to want to be flat. Aristotle basically came up with the idea that the Earth was round because of his observations that you can see different constellations as you move farther and farther south. The only way that he could come up with that to work is if the Earth was round. A couple decades later, Eratosthenes proved that the Earth was round by measuring the height of a stick at noon in Alexandria and Syene down in Egypt. And using a little bit of trigonometry, was able to work out almost exactly how big around planet Earth was. But Aristotle's the first one to think that it was round based on what he was seeing. And he, of course, came up with that geocentric view that the Earth was the center, which, based on just observations, makes complete sense. Because the Earth seems to hold still while you're standing on it, and all of the planets seem to be moving around. The moon seems to be going around this stationary Earth. The sun is going around this stationary Earth. The planets are going around the stationary Earth. It makes complete sense. He also came up with the idea that everything in the universe is made up of 5 different elements. Air, water, earth, fire, and this thing called quintessence. So what do we have Aristotle to thank for? Figuring out or coming up with the idea that the Earth is round. Ptolemy, between 90 and 168 AD. So this is a couple hundred years after Aristotle. Ptolemy came around, and he was a Greek guy who lived in Alexandria in Egypt. And he took Aristotle's idea of the Earth being at the center and improved upon it. The reason is that Aristotle's view of the Earth in the middle and the planets going around worked for the most part, but the observations that they were making did not match up with his model. The retrograde motion of the planets, the speed of the planets didn't quite work. Ptolemy, who was also a mathematician, came around and put epicycles on the epicycles. And when he did that, he made the observations match his model much more precisely. So this geocentric idea that the Earth is at the center of the universe and all of the planets are going around basically on epicycles of epicycles, but they're going around planet Earth, that is usually known as the Ptolemaic system, because it's this system right here that matched our observations pretty closely, that lasted for 1600 years. It wasn't until Copernicus, like 1500 years later, that things changed. So Ptolemy and the Ptolemaic system is basically the Earth is in the middle, everything else is around the Earth. As I mentioned, he was Greek, but he was living in Egypt, in Alexandria, and the Great Library in Alexandria is pretty much where the world's knowledge was located. If you were a teacher, if you wanted to become educated, if you were a thinker, a philosopher, a mathematician, an astronomer, a chemist, an alchemist, you went to Alexandria. That's basically where everybody went to get smarter. And he is the one who perfected the whole geocentric Earth is in the middle model. And it's named after him because he perfected those epicycles to make our observations match what his model was saying should happen. And this lasted for 1500 years. Basically, every educated person in the world thought that this was going on. This is what was taught. It became the central dogma of a number of religions, that the Earth was the center of the universe. Ptolemy wrote the Almagest, which is a book of astronomy, and in that he named 48 of our current 88 constellations. Capricorn and Leo and Gemini and Aquarius, those are all constellations that Ptolemy named almost 2,000 years ago now. We still have those same constellations. Finally, somebody with some sense. Copernicus. Copernicus rolled around and he put the sun at the center of the universe. Still not quite exactly correct, but he moved Earth as going around the sun. So he is definitely on the right track. Copernicus was Polish. He was actually a priest. And we'll get back to that in a second. But he was also a mathematician, and he was an astronomer. He looked up at the sky all the time. He is the one who created the heliocentric theory. Helio means the sun, and so he is the one that put the sun at the center and all the planets, including Earth, going around the sun, which means that Earth is moving. For him to be able to come to that conclusion that Earth is moving and the sun is not is quite a big leap, because standing on planet Earth, it doesn't seem like that. It seems the other way around. He mentioned this idea in 1514, and everybody thought he was crazy. Nobody else thought that the sun was in the middle and Earth was going around. Everybody thought he was crazy, so he kind of shut up. He shut up for about 30 years. It wasn't until basically he was on his deathbed and he knew that he was going to die very, very soon that he published his book. And the reason is that he was a priest. And the Catholic Church wanted Earth, basically where humanity lived, to be kind of the center of the universe. God made Earth special because that's where God's creation was, and if Earth was not the center, that would mean that God's creation was not the most important thing in the universe. Basically, the church was like, no, Earth is the center, there's nothing else that could be possible. And Copernicus knew that if he kept pushing this idea, the church would get pretty upset with him, and the church at that time was in the habit of killing people that disagreed with it. So he kind of just shut up. Not only because he didn't necessarily have a way to prove it, he didn't want to lose his job or be killed by the church, but also because Ptolemy's model actually predicted the motion of the planets better. His model of the Earth in the middle and everything else going around in perfect circles did a worse job at predicting the location of planets than Ptolemy's. And the reason is that Ptolemy's had those little epicycle things going on. Nobody could explain how those works. They don't follow any known laws of physics. but they were able to predict the location of the planets. Copernicus's did a worse job. So even though he made it more correct by putting the sun in the middle, it did a worse job at explaining where or predicting where the planets should be. As I mentioned, he waited until right before he knew he was going to die because he did not want to lose his job. He did not want to be killed by the church. And as it was, the church still banned his book. They took every copy and they burned them. Luckily, a number of his books kind of spread very quickly outside of the church's grasp, and his idea of the earth not being in the center anymore, the sun being in the center instead, kind of spread. Even though he died right afterwards and the church was trying to burn every copy of his book, that idea still got out there. So Giordano Bruno, he also was part of the church. He was a friar. Friars are kind of like monks. Monks live in a monastery. Friars are the ones who kind of stand on the side of the road and preach, and people give them donations. But he was part of the church. He obviously believed in God. He also had an imagination. And he started thinking, what's in space? What if I traveled to that sphere where all the stars are located? Could I travel past that? Why not? So he started thinking, what if the universe was infinite? And the problem is, at that point, the only thing that could be infinite, according to the church, was God. God, God, God. So Giordano Bruno basically looked at those stars and said, if we traveled to them, and they are not these little tiny pinpricks of light, maybe we could travel past. Maybe the universe is infinite. And what would they be if we traveled to those stars? Makes sense that they would be big, giant balls of fire, just like our sun is. So he came up with the idea that our sun is a star, that the universe is infinite. He also came up with the idea that the planets were moving kind of on their own. Up until that point, God had like a bunch of hands, and he was the one, he would take a planet and he would be the one moving it. I don't know if God has hands or not, but it's God that's moving the planets, and it's God that's causing the moon to orbit, and it's God that is doing all of this. And Bruno thought, why? Why can't they just kind of be moving on their own? Oh, church was not happy with that. So they gave him the opportunity to take all of that back. All of his thoughts that he was telling everybody and preaching, they gave him the opportunity. They put him on trial and said, you are wrong, we are right. You need to take it back. You need to renounce what you've been saying, renounce your views. And he's like, no, this is what I think. It makes sense. Why would I take it back? And they're like, no, you need to take it back. And he's like, no, I don't want to. And they're like, okay, well, we're going to burn you. He's like, I still don't think I should take it back. And they're like, okay, you're dead. And they burn him at the stake. So he's the first science martyr, I guess. I don't know what word you would use, because martyr is somebody who dies for a religion. He died because of his scientific views. He was burned at the stake in the year 1600. He was on the right track and got killed for it. Tycho Brahe, if you notice, he died in 1601, just 1 year after Giordano Bruno. Tycho Brahe was a rich guy. He wasn't very good at math. He wasn't very good at figuring out things. He was rich. He also had a lot of free time. And so he would go out and look at the sky. And he had heard about Copernicus's model of the Earth not being in the center, but the Earth going around the sun, and that made sense to him. So what he actually did is go out with all of his free time and make observations for decades. He built himself an observatory, and he would go out every single night, and he would record where all of the planets were, he would record where the stars were, the moon, the sun, and he had decades with a very detailed astronomical observations. And he tried to take all of those observations and put them together into this model that would work, because he knew that Ptolemy's worked better. So he was trying to get Copernicus's model to work by taking all of these observations. The problem, he wasn't any good at math. Not being good at math, he could not figure out how to get his observations to fit Copernicus's model. So he hired a mathematician. You may have heard of him. His name is Johannes Kepler. It looks like he's using chopsticks here, and I'm not sure why. It's actually a compass to draw a circle, but chopsticks. Johannes Kepler, after he graduated from university with a math degree, heard about Tycho Brahe and the fact that he wanted to get this math done, but wasn't very good at it. So Kepler, who wanted to figure out how the universe worked as well, went up to Tycho Brahe, and because Brahe was super rich, he worked for Tycho Brahe. And Johannes Kepler, the mathematician, took decades worth of observations and was able to work out how to make Copernicus's model work, how to make that heliocentric model work. And because there was so much data that Tycho Brahe had collected, Johannes Kepler was able to come up with his 3 laws of planetary motion. That everything orbits in an ellipse, that as you get closer to one of the foci of the ellipse, you're going to speed up, and when you're farther away, you're going to slow down, and that things that are closer in are going to orbit faster. He would not have been able to come up with those. Maybe he could. It probably would have taken a lot longer if he did not have all of those observations. So Tycho Brahe came up with the observations, just was really bad at math, couldn't figure it out. Kepler didn't have the observations, but was good at math, and so working together, Kepler was able to come up with his 3 laws of planetary motion. After he did that, figured out that everything orbited in an ellipse, Kepler's model worked better than Copernicus's, but it also worked better than Ptolemy's model. And Kepler's model of the sun in the center and everything orbiting around in an ellipse was the most accurate model of our solar system that had ever been produced. Accurate enough that we still use it.
The next astronomer who was alive during the Renaissance, Galileo Galilei, from 1564 to 1642. We've mentioned him a few times. He is the first one to take a telescope, look up at the sky. Most people up until that point had been using telescopes as, to see things on land far away, military generals, ship captains. He looked up at the sky, and when he did that, he found saw a bunch of stuff that had never been seen before. He discovered the 4 biggest moons of Jupiter, which are now called the Galilean moons. He discovered that they went through phases, which means that they were orbiting around Jupiter. He was also able to see that Venus had phases. And remember, phases happen because we're seeing different amounts of the lit up side of that planet. Because Venus has phases, that means that it was going around the sun. So here was finally proof that Copernicus was correct, that the sun was at the center and all of the other planets were orbiting around the sun. Looking out at the Milky Way, which is normally just looks like milk, where the name comes from, a big whitish cloud. When you zoom in with the telescope, you can see that that whitish cloud is made out of individual stars. He was able to take his telescope and point it at the sun and project that onto a wall, and he actually was the first to ever see sunspots. He did a whole lot more than just seeing things for the first time. He was actually a professor of mathematics and physics and astronomy at the University of Pisa, where he was actually a student first. And then he moved to Padua, where he was a professor. While at the University of Pisa, climbed up the Leaning Tower of Pisa and was able to drop things and time how long they took to hit the ground. He's the person who realized that if you drop 2 objects, and if you can ignore wind resistance, those 2 objects will always hit the ground at the exact same time. He would roll different sized objects down a ramp and time how long they took. He was actually the first person to really do the scientific method. Where he wanted to find an answer, and so he did an experiment, looked at what happened, recorded it, and found the answer to his question, which is why he is known as the father of modern science. He also was a private tutor to a couple of really important, influential, rich, leading families in Italy. Because he had a lot of really important friends, and he was the #1 science professor at a number of universities, he was pretty important and pretty famous. We'll get back to that in just a second. He published a number of books, and some of his books started getting him in trouble. So the dialogue on 2 world systems, the sun in the middle, the earth in the middle. And he basically wrote almost like a play. It's a dialogue. 2 people are arguing back and forth. One saying the earth is in the center, and the other saying that the sun is in the center. And the way that he wrote it, he made the person saying that the earth is in the center sound just completely ridiculous and stupid. And the person who said that the sun was in the center, was very smart and well-spoken. He also made it so that this person who thought the earth was in the center was part of the church, and the other person was not. And so when the church heard of this, they realized that they were being made fun of, and when anybody else read it, they would think, oh, the sun being at the center is the smart position to take. The church called him to Rome. At this point, there was this thing called the Black Death going around. So he had to travel through the Italian countryside, hoping to not get the bubonic plague. He got to Rome, was put on trial for heresy, and told to recant. And he kind of recanted. But not really. And there were a number of church leaders who actually wanted to put him to death. Luckily, he had a lot of really important friends. He was very, very famous. And the people that finally made that decision said it would be too much of a bad look if they killed the most famous scientist in Italy. So instead, they sent him back home and put him under house arrest. You can imagine somebody who wants to discover how the universe works being told that they can't leave their own house. For the last 9-10 years of his life, he was under house arrest. His daughter was actually in a convent just a few miles away. He was not even allowed to go and visit his daughter. He started to go blind, so he could not even do any science at all. So he died pretty alone, pretty miserable, not able to do any science because the church wanted their way of thinking to be correct. And anybody who went against that, obviously, if you go against the church, you deserve to die. Cassini. You may have heard the name Cassini, and that's because NASA sent a probe up to Saturn named Cassini. So Cassini lived a little bit after Galileo, and you can see that the telescopes are starting to get much larger. This one's in this photo is the size of a building. Cassini was able to see actual structures on the surface of Mars, something that nobody had been able to do before just because the telescopes were not good enough. He was able to figure out how long it took for Mars, for Jupiter, for Saturn to actually spin once on their axis. He discovered 4 never-before-seen moons of Saturn. He was actually kind of focused on Saturn quite a bit. And he discovered that Saturn's rings were not one solid ring, but they actually had divisions, and they were actually a bunch of concentric rings getting bigger as you moved out. He saw Jupiter's great red spot. Cassini is basically an example of when you get better technology, you can see new things, you can make new discoveries, and you can understand the world that much better. Roughly at the same time as Cassini, there was Christian Huygens. Christian Huygens focused a lot on Saturn. The Cassini probe that NASA sent to Saturn had a little lander named the Huygens lander, and it was Huygens that actually kind of went down and landed on the moon of Titan. I think we've watched that, but it's basically a video camera going through this greenish atmosphere and landing on a mountainside. But Huygens was not only an astronomer, he was also a philosopher, he was a physicist, he was a scientist, he was a mathematician. And Huygens actually invented the pendulum clock, which was the best method for keeping time for a couple hundred years, actually. So a lot of these guys were not just astronomers, but they specialized in a ton of things. Speaking of specializing in a ton of things, the next guy you may have heard of, Isaac Newton, 1642 to 1727, born on Christmas. If you were to ask Isaac Newton what he wanted to figure out the most, it would probably be not gravity. It probably wouldn't be anything about space. It wouldn't be how motion works. He actually wanted to figure out how light works. He's the first one to realize that light could be separated with a prism into different colors and then recombined. He's the one that came up with Roy G. Biv, red, orange, yellow, green, blue, indigo, and violet. He's the one who added in indigo. Like, what the heck is indigo? But he basically figured out this spectrum of visible light. And probably most importantly, more than any other thing that Isaac Newton ever did, he had a puppy named after him. Isaac Newton studied math, actually invented calculus. Somebody came up with this problem that nobody knew how to solve. And he's like, Give me a few months. I'm going to go home over Christmas break. He went home and figured the only way to solve it was to invent a completely new type of math. So that's what he did. He figured out how gravity works. I think the image of Isaac Newton that's most famous is him sitting under an apple tree, the apple bouncing off his head, which probably never happened, but he wrote about how light works, how sound works. He tried to figure out how to turn things into gold. Alchemy was the precursor to modern chemistry. An alchemist wanted to figure out how to turn everyday objects that are made out of metal, like a key, into gold. Why? Because it's worth a lot of money. He spent a ton of time trying to figure out how to do that. Obviously, you can't, so he never did, but he wanted to. He used ideas from Copernicus and Galileo and Kepler to come up with his laws of motion, to come up with his law of gravity, and he wrote what is probably the most important science book of all time, which is the Principia. This basically changed the way that science was done. It changed the way that we looked at the world, changed how we built things, because it explained gravity, it explained motion, engineering changed. It explained so much in a scientific, ordered way that had never been explained before. The effect that this had on not only science, but just in the world in general, cannot be overstated. Most historians, especially science historians, would consider Isaac Newton the most famous, one of the most influential, one of the smartest humans of the last 1,000 years. It's hard to overstate how important Isaac Newton was. Would we have probably figured out all of those things without him? Yeah, but it may have taken another 200-300 years. Isaac Newton, he was a good scientist. And as important as he was, this is one of his quotes. "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself now and then finding a smoother pebble or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." As much as he discovered, he basically compared that to finding a little seashell. Like, there's so much more to discover. He realized that all he was doing is scratching the surface, that there is so much more to science than he would ever know, which I think is the true mark of a genius. If you think you already know everything, you're not very smart. The smarter you get, the more you realize that you don't know everything. And Isaac Newton, as smart as he was, and as much as he was able to figure out, knew that there was a ton more out there. A couple other quotes that I think are pretty relevant. "We cannot teach people anything. We can only help them discover it within themselves." It's kind of what I'm doing. I can't really teach you if you guys are not willing to learn it yourself. Another quote: "Those things which I am saying now may be obscure, yet they will be made clear in their proper place." This guy was basically saying, what I might be saying now you think is wrong, but I'm going to be proven right in the future. Who do you guys think said this? This was Copernicus, who was right and was proven correct in the future. If you guys could go back and answer the question of the day, how has our view of the solar system changed over time? And